In the last section, we implemented our own shuffle method, which really just delegated to enum.shuffle behind the scenes. So remember, enum has a bunch of functionality built right into it for just about anything you could possibly imagine for working with a list of data. And we're certainly going to make good use of this module many times throughout this course. Also at the end of the last section, I mentioned that there was actually a surprising amount of complexity in just creating that list and shuffling it. So let's discuss exactly what I meant by that. Back at my Elixir shell, I'm going to create a new deck. And now I've got my deck, right? I can reference it and I see clearly ace 2 3. Now I can shuffle it and I've got 3 2 ace, or excuse me, 3 ace 2. And what I want to really point out here in particular is if I put in deck again, you'll notice that deck is still looking at a list of ace 2 3 instead of the 3 ace 2, which got shuffled. So this is a very important topic in Elixir right here, the concept of immutability in Elixir. Let's look at a diagram to help us understand what this immutability term is talking about. So on the left-hand side, we've got what I'm calling my deck, which is basically just like a variable holding a deck, like a list of strings in this case. Our cards module has a shuffle method, and we are passing my deck, or just deck as we called it, to that shuffle method. Once it goes into the shuffle method, we can imagine, okay, keyword here is kind of imagine that behind the scenes what's happening is shuffle is first copying the list, it then shuffles that new list, and it returns that new list. So the very important topic here, and this is constant throughout all data structures that we work with in Elixir, is that we never ever are modifying an existing data structure in place. We can never take some variable, my deck or colors, an array of colors, or numbers, an array of numbers, or whatever it might be, make some change to it, and then expect that my existing variable, that array is now changed. Every single modification method that we have in the language, everything that changes a data structure returns a new data structure. So we're not modifying any existing data structure in place, we are creating a new one and returning that. And that is exactly what we're seeing here in practice. We have some deck, we modify that deck. When we modify it, we are not changing the original deck, we are instead making a copy, changing it, and then returning that. And that's why when you see cards.shuffle here, and then we got the different array, and then we make reference to deck again, and we get ace 2 3 again. So again, this is just constant throughout the entire language. You're going to find this with every data structure that we work with. This entire concept, again, it's referred to as immutability. Immutability means that we don't change any existing data. Instead, we create a copy of the data and then change whatever we want, in some fashion. And so I think I've kind of repeated that phrase enough times here. You're probably getting the idea. As we work through the rest of this section, we're going to find that all these different methods that we create that supposedly modify our deck in some fashion don't actually modify the deck, but just return a new deck. And that's something that's actually really important. It flows with functional programming really well. We'll see that kind of aspect of why it flows really well, certainly when we start looking at, when we start saving a deck and dealing from it as well. So let's continue the next section. We're going to start working on how we can implement the contains method. So how we figure out whether or not a hand has a particular card inside of it. So let's tackle that in the next section.